All right, I added a subtitle to this. So this will be an interesting talk, I hope. I have to cover some context about the GIS effort and the most recent effort specifically for any of the rest of it to make sense. And it's sort of a narrative on a significant refactoring that we did based on working towards a stable release, which is a little ironic, and then some takeaways there that could potentially facilitate some conversation later on. So aiming for 3 birds with 1 stone. Historically, I have missed them all, but ideally, we'll do that all right. So in general, just the relevant background of those folks that aren't aware of what we've been up to for 8 years now, I believe, in the GIS working group. Just the fundamentals of some piece that will make the rest of what I have to say hopefully make a little more sense. Then the whole process of this refactoring we did recently, why and how, and then sort of what that led to throughout this process, which I'll save as a mystery for last. But so at the highest level, GIS, geospatial, geographic information systems, collection of tools, data, hardware people use to locate, describe features on the Earth's surface. So when we're talking about, it's often synonymous with place-related data or GIS data. If you can pinpoint that onto a point on the map or a polygon on, a polygon on the globe or a point on the globe, that is considered to be geospatial data. Gaia is the name of our tool, our main tool. It's also the Greek personification, or I don't know if we should start using deification of Earth with Odyssey conventions. Atlas was already taken. I offered to trade. They seem pretty set in their ways. Exposomics, which is the heart of what we're getting at, and often people don't run into that. And I believe it's quasi under the umbrella of larger omics. Some descriptions say it is or not. So this could be a little bit of an omics study as well. But the field of study that investigates the impact of environmental factors on health by examining totality exposures throughout a person's life. So the human exposome. So like built environment, access to care would be one relevant to this, pollutants, any sort of like social factors that may have limited things. Really anything that has to do with a place on the Earth and that you want to tie to a human and do that study with. And it kind of falls in line with the idea of the more comprehensive of a patient journey that we get, more reliable evidence or insightful evidence we can get. So it's just adding to that. And the problem space where I know these use cases pop up all the time of, hey, we need this one variable from this one geospatial data set. So hopefully at least some of the crowd has been jaded by that experience and realizes how burdensome that is to do. There are always one-off efforts. There's always some issue with imports. It's a huge pain. And the typical solutions to this in a more harmonized approach are often not really all that extensible as well, where every data source you need to add in sort of changes the whole thing, and you kind of need to refactor each piece of it, at least with a lot of what we've experienced. So what I've dubbed as solution space is prioritizing multifaceted extensibility, which is a new term for me, but essentially extensibility in several dimensions. One is on the software development side of it, having a robust foundation that is intended to scale for our framework, and what I'll get into later. That is Gaia. That is the heart and soul of it, and really doesn't have too much to it, but with the intent that extending that effort would be very clear. And then for this effort as well, which might not be as clear at this point, but we're essentially building repositories as a community of data sources of interest. And once that data source is properly defined with its metadata, that gets added into this automation routine. So the idea that we're all contributing together, and to the point here, to make that as easy as possible for people to do so, which it was not, which led to the refactoring with a little foreshadowing. Here is a diagram that our work group uses. I have feelings about it, but yeah, here it is. This is how it interacts with the OMOP system, essentially. This top side of it, I'm sure you all see, everything's going into OMOP. And this section down here is sort of what we're referring to with the geospatial side of it. So we have all these public place related data sets out there, and then we catalog essentially recipes that are, we don't store the data in our catalog, we store the means of which to go get them. So parameters to feed into our static functionality that will go and get any data set that has a proper metadata record for it. And this retrieve stage data. Geocoding is the prerequisite, unless you're dealing with zip code data, of working with Gaia. You take your patient address info, pull down a geocoder changes street address into lat long so to put you on a point to the map, and that's really all you'd need to facilitate that. But again, you can do it with zip code if that's all you have as well. And then there's this OMOP.js extension piece of it, which I will touch on separately. But the idea is you're combining the measurements, the exposome, the factors that you're finding with the same patients in the same structure and be able to run the same analytics with those additional features. And the next slide is the same one where I highlighted in red here. Apologies in advance for all this clip art stuff that's going to be going on. But that's the part we're interested in, just this little tiny bit here, which is the retrieve and stage data, which is Gaia. It looks small in comparison to this larger side, but it's quite large. Whoops. So recent efforts post-symposium. Symposium was big for us. We had a very successful symposium, and we had a lot of functionality in a lot of different ways. And it's building off, catalogs, geocoding, vocabulary building, all sorts of stuff. And it was great, and we want to hit the ground running. And the takeaway at the end of that was our foundations are shifting from underneath us. We absolutely need to prioritize stabilizing the foundation. Just like imagine the common data model was changing all the time. You're trying to build tooling on top of it. It just doesn't work unless you do that. So we pivoted to focusing on getting that stable release done as the main priority. And then while reviewing that, looking at use cases we haven't handled yet to see if there's anything that would warrant us needing to do a refactor beforehand. If we know we're going to do it eventually, we really want the stable release to not just immediately need to be ripped up. So stuff that would be significant, and if there were any, and spoiler, there were. So just a quick view. You guys have maybe heard of the Odyssey GIS extension, and really it's two tables in Odyssey, location history, and I think it's been renamed environmental exposure instead of external exposure, the other way around. But basically location history is a mechanism. I'll get to that in a second anyway, on a different slide, but it's just these two tables. The stuff to the left is on the other side. Sorry, how much time do I have to go to?
You could take another 5 or 7 minutes, something like that.
Alrighty, should have timed that better then. And the other side is the extension for the OMOP vocabularies, and that's what comprises that. In order to integrate with Odyssey, here are the pieces that are missing. You need to geocode your data, which I mentioned. You need to implement something like location history. This was previously a part of the CDM 6.0 that was nullified. And then basically there's one-to-one relationships between person and location if you want historical locations, or to specify the subtype of how they related, they worked, they lived there. That's not there. And then representing place-related data at the person level. And basically this is a glorified measurement table with a couple more provenance fields on it, but this is the representation where in the use case that you do want to bring your place related data at the person level into OMOP, where that would belong. And this is the beautiful graphic that I am so proud of that I made this morning. So there's the distinction between the Odyssey GIS framework, which is the amalgamation of all the tooling that we're doing. All of that sort of depends on Gaia as that fundamental principle as it maintains the data there. But yeah, just make that distinction. So Gaia is one piece of that puzzle, and often we have some semantics issues with how these things are named. Now I feel like I am running for my life here, but Yeah, so Gaia is this underlying backbone infrastructure, the nuts and bolts of what makes everything work here. And it is essentially, I'll just skip this one. This is a little more intuitive given the time. It's a mechanism that you essentially deploy a Postgres database, usually in a container that has a schema inside of it, and there's a catalog of metadata records that you pull down from a central repo. And those metadata records give you all of the functional parameters you need to automate going to get that data from the source, bringing it locally, unzipping it, unpacking it, importing it, and then converting it into our common data model. And that's something to stress as well. It's a very simple common data model, but the data model itself, I feel like I should ask how much time I have. Sounds like it's running out.
If you still have, you could take another 5 minutes if you want.
Okay, perfect. Yeah, I just want to get this done here. On the right is a example of the load variable function, which is essentially how we sort of bookended this whole thing, where if we call load variable, you have an identifier for a specific variable, it will run the whole function of, do we have that data source already? If not, go download it, install it, and get it. Did that data source depend on another data source? If, for instance, it had FIPS codes, but we need the actual geometries and do that. So it's a full stack implementation based off of if you want a full data source or even a single variable within those. And those variables are being assigned concept IDs because of that previous work that I did, or that I mentioned with that Paulina and Jared were knocking out. And I believe Jared's going to speak to that after this as well. Yeah, so this is basically the end of that translation format of the simplest common data model you can imagine. And instead of person-centric, it's geometry-centric. So Middlesex County, I think that's Massachusetts, happens to have an attribute of estimated poverty rate of 25%. These are two completely different data sources that would link together. But, oh, sorry. That's the model. We're breaking every kind of data source that you have that has some affiliation with a point on the globe can be put into this model, because we're just putting all of that into geometries and then breaking down any attributes into essentially measurements. And one thing, I guess, if you were interested in some open source development side of it, there's a little more power to this now, a little more sway, because they're starting to systematically take down all of these data sources, especially social vulnerability index and things like that. So we need to revisit how we're doing that. And now I've given the context to get to the actual issue at hand. So I'll try to rock through that super quick. So part of this metadata format that I was referring to is two tables: data source and variable source. Variable source, there's many to one inside of a data source. Essentially, here's how you get the bulk of the geometries, whatever data inside of your database. And if you want to pull in variables in particular, here's the logic to translate that into our model. Here's logic to translate that into our model. And this is so basically download method is file, it's a parameter, download subtype is zip, you unzip it, what kind of file should you expect, what kind of boundary type that's being mapped to a concept ID, et cetera, et cetera. And yeah, so here's the point of this, I guess. So the driving use case of looking at this before refactoring was we had a use case of a Python extension of the framework we've done, and everything that's built on top of our framework has been R so far. And it made us a little introspective as to why did we have R so deeply embedded into the GIS framework. And I will note that this use case did come from Chiron. So Paul might be playing 4D chess here with us that all turns out with this, I'm not sure. But essentially, it was a big issue, and we decided that we were going to refactor to take care of that for multiple reasons. Essentially, it just sort of nullifies exactly what we're trying to go for, an extentability. And I guess not quite sure how, yeah, I mean, I'm not going to get too far with this much time left, but so here's what it looks like with our legacy implementation. I will refer to it is basically all this logic is either descriptive, it's either how you go and get the data or ingest it. And there's this one piece, which is really the heart and soul of what makes this automation work, is this conversion logic of you have the staging data in its raw form, you know the destination format, how do you convert that? And that varies for every source and even variables within that source. And this is the real root of the problem. Up here on the right is the ugliest version I can find of it, just so you can all stare and disprove at it. But it's essentially written in R and very cryptic for those that don't know R, and difficult to append to, as well as difficult to try to do any sort of automation in the world of LLMs, where that is something that can easily be done. Asking that to convert into Dipler mutates is not as intuitive. And once again, this puts an underlying foundational dependency on R deep at the foundational level, so that a Python extension would need to somehow run an R engine to deal with any of that. But essentially, if you look at what that R translates into, it's an insert statement. And we have the benefit here of always having the same target table. So our actual metadata we need really is just what are the values in the select statement, and if there is a where statement, because they're already in the database, we know what they're going to. And so what we came up with was JSON instead, JSON instead of R. And that's not all that functional, but it works very well. It's out of the CICD playbook for sure. And how difficult would that be to implement? 20 minutes. Very, very, very not hard at all to do. I'll just summarize, given the lack of time here, of what comes up. So essentially, that gave us a thirst for blood of removing R from our system. If you can see on the top right here, that's the thing we just fixed, just this tiny post, just where R used to be inside of our metadata table, but our entire functional layer was built on R entirely. And so we started looking at some of those edge cases and difficulties, and weighing the idea of why not collapse our entire foundational structure down into PostGIS, which I know sounds insane. And I'll post these slides, maybe a better version of those slides at some point, but we got going with it. And then, yeah, it was very, very easy to do once some of these things were recognized as problem areas. But anyway, oh, I didn't want to do that. I did just want to, slightly touch on that last one because it was kind of talking point. So throughout this process and the refactoring process, I'll be quick on this. I noticed quite a significant trend, especially with the proportion of items that involve this, but lots of the Odyssey development principles or patterns, or however you want to call it, keep popping up in everything we're doing. And it's not like we're seeking out these intentionally, only discovering by chance of like, oh, I've seen something like that before. I mean, obviously, simple things like the common data model, like that whole concept of why you would do that and why you would build on that makes sense to the Odyssey stack. But like JSON to SQL conversion, CICD, we needed a mechanism to go get the data from the source. I had just been working with the vocabulary working group on a community piece and found out they used PLSH to go and retrieve all their files straight from Postgres already. Importing the files, that was already solved by somebody at UMiami. Persistent vocabulary mechanisms, inserting those, of course. Environmental exposures, a spin-off of measurement. Our catalogs, essentially Athena, but instead of concept IDs, it's metadata files. Documentation structure we stole from the oncology working group, which I think the oncology working group stole from the CDM working group, but and then the core package without Odyssey dependence, where of Gaia is akin to database connector and SQL render, where it can still be a fundamental dependent package, but work on its own and outside of Odyssey as well. So I guess the final thought was, is it possible to, I don't have an answer, so I'm just posing a question, given it's a conference of developers who like to noodle on these things. Is there any way we could possibly improve how to facilitate and streamline this knowledge sharing? Because all of this is accidental and all of it saved so much time, and being able to do that and build that up without having to just luck into encountering these things. And I know it's generally trying to share that information better, but there's a lot that it seems like we can leverage from each other that isn't as explicit as it could be. So maybe it's something to talk about at some point. But anyway, sorry for going over if I did.
No, Rob, that was great. Thank you so much. And I think it's fun is the place that we really have a nice conversation that crosses different repos is the technology advisory board. It's really where exactly that's the place where we like to do these noodle things for how do all of our pieces come together and how can we make it more, adaptable and seamless. So I think it's great. Thank you.
You got it.
Yeah, thank you, Robert. I see a couple questions popping up. With just a note for the lightning talks. Let's put all the questions in the chat, and then presenters, if you could, after your presentation, come in or take a look at the chat and see if there's any questions left to answer. Thank you. We're going to keep moving here. Jared Houghtaling next is going to give a presentation on custom vocabulary builder.
All right, great. Thank you so much for the introduction. Awesome work, Roberts. And I will be referring a little bit to Gaia in this talk. Hopefully, can you all hear me okay? And you can see my screen just to confirm before I dive in. And
Yep, you're all set.
Awesome. Okay, so going to talk a little bit today about the Custom Vocabulary Builder, or CVB, which is something that kind of grew organically. I'll give a little bit of the backstory as well. But it's more or less an automated process that brings together clinicians to validate mappings and some kind of continuous integration workflow to actually produce a set of relational custom vocabulary. So this 2 billion range vocabulary with relationships and ancestry and other mappings that supports kind of analytics in a provisional sense, while the vocabulary terms that get created can be evaluated and reviewed and validated kind of by these broader, more thorough mechanisms within the vocabulary team. So before I dive into all of this, I just want to stress that this is complementing existing processes. It's allowing essentially very particular use cases like the GIS case where there are terms, these exposome terms or SDOH terms that are not present in the current standard vocabulary, but we need to have some sort of OMOP way of representing them in order to do OMOP-based research with those concepts. And so this enables you to essentially create this set of custom terms with the help of clinical and ontology experts in a way that's becoming more and more automated, I should say. And so I'll talk about what that looks like as we go through. Bit about me, I'm working now at Tufts Medicine, recently joined the research faculty and working closely with Andrew Williams and also with Robert and Pauline and Kyle and others that you have met. Okay, so kind of already explained most of the key session items. So I'm going to give a little context to where this is coming from, why we're kind of needing to create these terms and how we're doing it. I'll talk a little bit about SESOM for those who are not familiar, what that is, why we're using it, and how it kind of plays into this whole pipeline. Then I'll get a little bit into like the data engineering and DevOps aspects, where we talk about like the CICD workflow, how this all fits together from a Google Sheet all the way through into a private database and back onto GitHub into a version control Delta vocabulary, which I'll talk about, as well as the metadata, so this mapping metadata, this kind of mapping provenance that we're able to capture and kind of maintain over time with deprecations and updates. And then lastly, I'll get into kind of use cases. So where we're currently using this, where it's started to make an impact, GIS being one of those use cases so far, and what I think is coming next. So for those of you who were at the European Symposium a couple of years ago, I presented a poster actually about some work that I did when I was working at Eden's Health. That's a small company in Belgium. On a lot of different Eden projects. And in support of these Eden projects, we kind of developed this workflow to create 2 billion concepts. And it was somewhat bespoke, and it was really manual, like really had to go in and spend a lot of effort to actually tailor make each of these implementations. And at the end of it, the output, we didn't really have very good mechanisms for version control or sharing or anything like this. But I think the underlying concept, maybe no pun intended, but the underlying kind of workflow helped support research across a variety of projects. And so with that kind of knowledge in mind, and I'll dive into SESOM next, but with that in mind, we wanted to kind of scale this and make it a bit more, say, generalizable and easier to implement, and also hook it up with some automation. So kind of some backstory there. Income SESOM, so Andrew and Paulina, and actually many others at Tufts are major proponents of SESOM, which is also Melissa Hendel and some others have kind of pioneered this idea of the simple standard for sharing ontology mappings, effectively a relational framework for capturing and sharing mappings between various terminologies. And so what you see here is kind of that, say, a multi-table or a relational framework of that SESOM model. And what we're doing as the starting point of the CVB, we're actually flattening this relational structure out, but we're using essentially a single tabular version of this SESOM as our kind of starting point for clinical validation and our starting point to start to construct these custom vocabulary terms. So think of it, we squish all of these tables into one single long table or a wide table, and each row is effectively a source to a standard mapping with some sort of relationship identifier, or a source with no possible mapping and some additional context about that source that tells you where to put it within the vocabularies and kind of what details to give it. And so in comes the CVB. So this is a bit of a busy diagram, I should say, but if you start to work from left to right, on the left, we actually just create essentially a glorified Google Sheet, which is a familiar environment. It's easy to share, easy to work with, and we're able to share this Google Sheet with clinicians. And like I said, that sheet is structured in the SESOM way, and these clinicians get typically clinicians or ontology experts or anybody who can validate our mappings. They get a little bit of training. We walk through kind of the structure and what we expect. And then where kind of the power comes in is each of these Google documents has this apps script integration available behind it. So if you go up into, I don't know, if you open a Google Doc or Google Sheet, and there's a little tab up at the top, and you that's, I think, apps, drop down to app script. And don't quote me on that now. But there's a way to actually get to an application script that you can trigger based on events in your document. And so what we've done is we've written some of these app scripts, and you write them in this kind of Google script language. It's essentially JavaScript, but slightly different. And those can make changes on your sheet. So like we, for instance, can lock rows once they've been reviewed. But more importantly, we can also send output from the sheet off to GitHub. So we can integrate what's happening in this kind of very nice, interactive, easy to use Google Sheet with the version control and kind of CICD potential of GitHub. And so that's what we do. So we have our clinicians working and validating these mappings, and daily or whatever frequency we want, we ship off the kind of output of what they're doing onto GitHub. And we end up with these mappings in CSV format on our GitHub. And that's where then the fun begins, because we can set up a GitHub action that actually ships these CSV mappings off to a self-hosted runner, where then they get interfaced with a vocab server. So the mappings then get checked against a kind of current vocab server that is in some cases specific to the project. And any new mappings get kind of created or let's say transformed into their OMOP vocabulary relational structure. There's some validation, there's deprecation that goes on, updates. All of this kind of building logic is happening out here. Once that's done, the delta output, so everything that was not in the Athena kind of gold standard vocabulary, gets shipped back to GitHub, where it's then available as a set of delta tables. So everything that's, say, unique to the specific project that's not in the Athena vocabularies, but is a 2 billion concept that has all of its various relationships. And that includes the concept relationship table, all these other kind of vocabulary tables that you're familiar with. They're all stored then as delta tables together with this mapping metadata, this kind of underlying provenance of who did the mapping, how they did it, why they chose it, what the confidence was, all of this kind of relevant information associated with those codes that gets spit back onto the GitHub repo. So in the end, your repo contains the source mappings, the logic that needs to transform those mappings into OMOP, and then the resulting delta tables. And the magic then is happening on the kind of CICD side. In this case, it's on Azure. Okay, so this is more or less what I was talking about. So we have the data entry validation, we have the continuous integration over here on Azure, we have all of our on logic held in GitHub that actually executes here on the runner, and then we have our version control and dissemination processes back on GitHub. I went through a lot of detail in that last slide, so I'm kind of just showing this here, but I just to re-emphasize, right? So this is essentially what our spreadsheet looks like to a reviewer. This is what the app script looks like. where we're able to actually use that app script to bring in data from the Google Sheet into GitHub and vice versa. And also, like I said, we can use the app script to do fun things within the spreadsheet. So we can lock rows once they're validated. We can assign particular rows to certain users. You can do some kind of clever things to help with your user experience as well. So that's we're using a Google Sheet environment for that. The build pipeline itself, it's very bare bones, I should say. So it's a SQL-based implementation executed with essentially bash script. So it's a bash script that launches a bunch of SQL scripts to execute the various logic to check mappings against the standard vocabularies and to do validation and to kind of do these updates and inserts as we need. But the nice thing is it's from like a computational perspective, we can use a very lightweight runner to actually execute this. We don't need any sort of bloated packages or anything like this. It's quick and relatively transparent to launch this and get it running. And so, like I said, it runs on a very lightweight self-hosted runner. That's here. So more or less, this is a small Ubuntu container that is listening for jobs. And once GitHub says, hey, we need you to build vocab, it kind of executes this set of SQL queries against the vocab server and then sends back the delta back to GitHub after that. And that delta that sends back to GitHub looks like this, right? So you have this set of delta tables. This is not the complete set, but it's essentially CSV files that contain your 2 billion error concepts, the relationships, potentially additional domains or concept classes, as in the case with GIS. GIS is an interesting case I'll get to in just a second, because there are multiple vocabulary elements beyond just the concepts themselves that are necessary to capture GIS terms. And then, as I mentioned, you have this mapping metadata CSV, which contains information about who performed the mapping and how it was performed. And it also gives a trace of, if you wanted to know why source code A is mapped to concept C, you can actually go into that map metadata file and trace where that came from at any point in kind of the versioning history. Okay, so to talk a little bit about current use cases, I think I'm doing okay on time. We have GIS, which Robert just talked about. We have psychiatry working group, which is our newest use case. Mimic 4, which Brian Gao and the psych team, so the PhysioNet team are busy with. It's also relevant to Chorus, as well as Chorus Bridge to AI, which is this broad 15-site consortium that I'm part of. This is actually in a different repo, not CVB, but same process, and then potentially yours. I think there's lots of use cases that could potentially integrate something like this. Little shout out here, Brian is currently updating the Mimic 4 to OMOP ETL on the Odyssey repo or Odyssey organization with this new vocabulary approach. So take a look, he's got a PR open if you want to check that out. It'll be nice to have kind of a robust version of that ETL that references these new Mimic custom concepts in a more transparent way. Okay, I'm going to go quickly then through the use cases, but more or less GIS, the vocabulary package for GIS actually contains 3 different components. It has a social determinants of health piece. It's got a GIS piece, which is has kind of your vectorized features, and then it has an exposome piece, which is like various toxins or environmental pollutants and things like this that people could be potentially exposed to. And so each of these kind of components has its own set of domains and concept classes, as well as its own set of concepts. This spaghetti slide is kind of an ugly version of what Robert just presented, but this is kind of the ETL workflow for integrating some GIS data into this external exposure table. So if you start with a location history table, you can spatially join that location history on your, let's say, PM 2.5 data, which then has its associated concepts generated by the CVB to say, okay, it's this 2 billion error concept is associated with my exposure to PM 2.5. And at the output of that, you get this external exposure table, which describes like a person, a type of thing that they were exposed to, and then the associated value of that exposure over a given period of time. Down at the bottom here, I did give a talk recently at the PLP working group where I showed how you can actually create a PLP model using the custom feature engineering using this PM 2.5 dataset. And that talk also has associated vignettes that are now in the PLP repo. So take a look at the PLP repo documentation. You can see kind of a description of this process in action. And like I said, the CVB, the vocab builder, is what we're using to then describe the, in this case, the exposure to a particular pollutant. Okay, and then this I will go very quickly through because this is a very busy slide, but the Chorus Bridge to AI Consortium is a set of sites that are essentially submitting data centrally. And before they're submitting that data centrally, they're standardizing it, they're linking it. It's multimodal data, so it's not just OMOP data, but it's imaging and waveform and note data. So they're going through all this effort to standardize and link that data before they can send it centrally, and we can merge it together and make this kind of broad OMOP-based multimodal data set. In that standardization process, though, there's a lot of specific concepts, either waveform related or ICU related or flowsheet related, that are not currently represented. And so we have used this kind of custom vocab builder to represent those concepts and disseminate them to sites, so that we kind of have this project specific working ontology that's being referenced. Again, same framework for doing this. We have a whole kind of set of clinical validators that are going in, looking at how we've mapped these are the concepts that we're creating, making updates, making changes, and that's then getting represented in this vocabulary that's then being used by sites to do this standardization. And so what I want to talk about is kind of a next step here. So closing the loop, right? So a lot of what's shown in this Google sheet is manually curated at the moment. So Paulina has done a tremendous amount of work manually suggesting mappings for things that then get validated or updated. But where we would like to go, and so I guess all that to say, these two arrows, right? The missing mapping centrally and missing mappings at sites, the suggestions for those are carrying a lot of weight in this diagram. So where we'd like to go is actually, and we've started to go here, is to implement a mapping pipeline where sites are submitting their unmapped codes, which then go through a similar process of suggestions using things like Usagi or Jackalope or some of our custom algorithms to do mapping suggestions. And the output from that suggestion pipeline is then getting committed back to GitHub into kind of a suggestion CSV that then gets pulled into a Google Sheet for validation. So we kind of have an upstream pipeline now that's supporting our mapping and suggestions, and then those mapping and suggestions get validated manually and then pumped back through what I just talked about in the CVB. So this is where we're headed. We've done some preliminary testing, and we have kind of a beta version in progress on the Chorus side, and we're hoping to bring that over into the CVB repo here, I think, in the next few months. Okay, other next steps, I'd like to kind of start with a tighter integration with the OHDSI vocab team. We've already kind of started that process at Tufts. We have some upcoming meetings to discuss this further. Looking at templating and parameterizing in order to scale and expand to other use cases. Trying to really pressure test this thing, looking at how can we scale it easier? What's the user experience? What is the quality of these resulting vocabularies, and then kind of what can we do to make them even better? And then the last bit is really an intensive validation of this underlying builder logic at kind of the heart of this whole thing, to make sure that it's accurately capturing all these weird additional edge or use cases. And there again, more work with the vocab team on that piece as well. So Paul said it nicely, standing on the shoulder of giants here. I have a lot of acknowledgements, and this is not by any means a comprehensive list, but I just wanted to give a few shout outs. So Paulina has done a tremendous amount of work on the vocab side with the mappings. Kyle and Andrew and Robert are all awesome colleagues, especially with regard to the GIS work. Brian and the PhysioNet team have been doing great things with Mimic and have been very helpful in that piece of it. Piper, Ronaldo at Minnesota and the psych work group in general have been very useful. I also want to shout out to Freya and Lars and Eden's Health in general for kind of the early stages of this work. And then all of you OHDSI members on the call, and generally the Chorus Research Consortium. So thank you all for listening. Hopefully this was interesting and inspires some new use cases. And I have some useful links if you want to check out more or learn more about some of this work going on. So thank you all very much. And that's all I have.
Great. Thank you, Jared. Looks like you already got a couple questions in our chat, but thank you for joining us. Jared's traveling today, as is our next presenter, Núria Mercadé-Besora. She, I believe, is actually in Sydney right now. But Núria, if you want to take the stage.
Hi. Yes, I'm in Sydney at the moment in a hostel, so not the best conditions for the presentation, but we'll make it work. Do you hear me okay?
You sound great.
Yeah? Okay. So I'm gonna share the screen. Okay, so my name is Núria Mercadé-Besora, and I'm doing a PhD at the Health Data Sciences group in Oxford at the moment. And also I have been helping out in the development efforts of Darwin and OHDSI packages together with the group. And today I'm going to present the CohortConstructor package with whom we've been working in Oxford, especially with Edward Barn, that his name appeared previously. So the aim of this package is to support building cohorts in R. And the code of the package is publicly available in the OHDSI GitHub repository. And currently the version 3.5 is available in CRAN. Also in the presentation, I'll try to go through how does it work and the functions that it has, but I cannot go very deep into that. But there are plenty of vignettes in the website where if you are interested, you can check. And also if you think that something is not properly documented, feel free to open any issue in the repository. And also the package is built on top of other packages. And if you are interested and you want to know more about that, Ed has been writing a book that is free and online, and it's called The Tidier Programming with Databases, Applications with the OMOP Common Data Model. So feel free to have a look at this. So let's start on the package. In this package, the pipeline to build cohort consists of basically two steps. On a first step, we could create a base cohort. This base cohort is one that is either defined using only clinical concepts, for instance, all the concepts that represent asthma diagnosis, or demographics. As an example, we could take all females when they are age 18 or more in our database, and this could create a base cohort. And in the second step, we would transform these base cohorts to meet the study-specific inclusion criteria. So for instance, in a study where we are studying asthma and we want to stratify by age, more than 18 or less, and as a sensitivity, we want to require 1 year of previous history. This combination of strata and requirements would result in 4 cohort definitions that would result in instantiating 4 different cohorts. However, when we use this approach, we would create the base cohort, and then we would use curation functions to apply the prior history requirement and stratify. So to do that in the package, we have a set of functions that we can divide in 4 categories. The first categories are these functions that are used to create the base cohorts I have just explained. And then the other 3 are to curate them. And we have functions to apply requirements and filtering, functions to update when subjects enter and exit the cohort, and also functions to transform and combine cohorts. I'm gonna go through these 4 sets now. So the first one, to create base cohorts, we have 4 functions: demographics cohort, the concept cohort, and measurement cohort. In the first one, the concept cohort, you would create these base cohorts based on concepts, and in the measurement cohort, you can require a measurement result. For instance, a BMA measurement between a certain numeric range. And then we also have a function called death cohort to create a cohort that would be basically the death table in the OMOP database. So here is an example of how we would create a demographic, like a base cohort based on demographics in R using the package. And in the inputs, we would have the CDM reference object, which basically has a reference to all the OMOP tables, person, observation, conditions, all the tables. And then you can specify the demographic requirements in terms of age, sex, and minimum prior observation and future observation. And also I'm gonna take this first example to show you how a cohort table object looks in R. So you have like this table, each cohort called this time, where you have the cohort ID column, the subject ID, and the cohort start and end dates. But then you also have some attributes to this object that help us work with cohort. And these are settings that relate the definition ID with the cohort name and other variables that help us know what the cohort contains. Then we have the counts, how many records and subjects are there. And then the attrition, in which you can see for each the inclusion criteria you have applied, which impact did they have in terms of number of records and subjects. And now, keeping in the base cohort, when we use, instead of demographics, concept-based cohort, the way that CohortConstructor builds them are based by domain instead of by definition. To explain it, I'm going to use this example where we want to create 5 cohorts: asthma, COPD, diabetes, acetaminophen, and warfarin. 3 of them are based on concepts of the domain or condition, and 2 of them on the domain drugs. Usually we would create these 5 cohorts separately, so it would require 3 interactions with the condition occurrence table and 2 interactions with the drug exposure table. However, when using CohortConstructor, as we build them by domain, we will interact once with the condition occurrence table to build the 3 cohorts based on condition concepts, and once with the drug exposure table to build the acetaminophen and warfarin cohort. And having explained that, here is an example of how we can do that in R. So the first step would be to get a code list. In this example, I'm using the code list generator package, which is a Darwin package. And I'm using it to get 2 code lists, one for diclofenac and another for acetaminophen. And in the second step, I'm using CohortConstructor to create a cohort table that contains these 2 cohorts, one for diclofenac and the other one for acetaminophen. And same as before, I have to enter the CDM reference object, then the code list, and finally the name that I want the cohort to have. And now if we look at the settings of this newly generated cohort, we can see how it has 2 cohorts, one for acetaminophen and the other for diclofenac. And in this case, as it's a cohort based on concepts, we have another attribute, which is the cohort code list. And we can see for each cohort definition, the name of the code list used and which concepts do they have. Explaining now the second set of functions. These are part of step 2, the curation of cohort. And on requirement and filtering, we can apply requirements on demographics, which are basically on age, sex, prior observation, and future observation. We can also require that we only want the first or the last entry, or any entry like the third entry of a person in a cohort. Then we can also require the presence, absence, or a certain number of intersections with other cohorts, concepts, or tables in the CDM. And finally, other requirements like require days to be in a certain date range or to have a minimum number of counts. As an example, to the medicine cohort that we have instantiated before, I'm going to require that we only want the first record per person, restrict to subjects that are 18 years old or more at the start date, that are females, and that have at least 30 days of prior observation. And we can do that with these two functions and this small amount of code. And each of these requirements is recorded in the attrition, so you can later check the implications that each of these decisions had. When we go through in the time manipulation functions to update start and end date, we have functions to change the cohort exit, and this can be set to the end of observation, the day, or the death date. Also, we can, if we have other columns in the cohort date columns, we can move the end date to the first of these columns or the last. And we also have this to update the cohort entry to the first or the last of a set of columns. And then we also have a couple of functions to trim start and end dates to string them so people in the cohort meet certain demographic requirements or to be within a certain date range. We also have the padding functions where you can add or subtract a certain amount of dates to the start or end. As an example here, we change the end of the cohort end to the end of observation. In this case, as a cohort cannot have overlapping entries, if a person have more than one record within the same observation period, this would be collapsed together. And in this second example, we use the trim demographics function to make sure that people in the cohort contribute while they are aged 20 to 40 years old and if they have at least 1 year of previous observation. Now I'm gonna go through the last set of functions. These are transformation and combination. And here we have functions to split cohorts. These are year cohorts and stratify cohorts. The first one would create different cohorts for each of the contributing years. And the second one, you can stratify a cohort based on other columns. Then functions to combine cohorts, these are union and intersect cohorts. Then to filter based on a cohort ID or to sample a certain amount of subjects for each cohort. With the match cohorts, we can create based on a cohort a match cohort of the population in your database based on sex and date of birth. Then we have the collapse cohort function to concatenate entries within a certain amount of days. And finally, some utility functions to rename and copy cohort. As an example here, I'm gonna use the intersect cohort to create a new cohort that contains people that are taking acetaminophen and diclofenac in the same time. And when you create this new cohort, the intersection cohort, we can see now the attribute cohort code list is updated, as now people contributing to the cohort have both code. So that's all so far. Thank you so much for your attention. And just to mention again that the package is in the OHDSI repository, and if you are interested, we look forward to your feedback, your contribution. So feel free to open any issues or pull requests. Thank you so much, and I'll be happy to answer any questions now.
Great, thank you, Núria. Any questions, please post them in the chat. I did just get a notification from someone that they were not able to access the chat. I hope most of you are. But I do want to keep things moving. So again, thank you, Núria. Excellent presentation. We're going to move. Yes, Daniel?
Yeah, I just wanted to point out Richard's question in the chat. I can certainly repeat if desired. He has one most recently.
Oh, great. Yes, I see it. Núria, do you have access to the chat to answer that?
No.
You don't. Okay. The question is, does the manipulation of the cohorts with filters, restriction, transformation, combination operations happen within the connected database or on the user's machine, like with DuckDB? And then 2, are there any functions to check for potential logical or data issues with the cohorts as the user is creating them within the tool?
Yeah, all the cohort operations happens in the database side, not in the local machine. And sorry, the second question, could you repeat?
Second question was, are there any functions to check for potential logical or data issues within the cohorts as the user is creating them within the tool?
Yeah, so for this, I guess the cohort attribute, such as the attrition, can help a lot because you have there every step that is being taken within the function that the user cannot really control because it's happening inside, and you can see the impact that it has. And with the, well, if we have another package, the cohort characteristics, that creates a really nice diagram to see how the flowchart of the cohort creation works. And there is also the cohort code list to see if it is what you expected. And I haven't mentioned it here, but there's a package in the OHDSI repository called Phenotyper that where you can, well, it provides you kind of a diagnostic of the cohort you have created using CohortConstructor. And there, I think it's a really complete diagnostics where you can see if what you were aiming to capture in your cohort is really what you are capturing.
Okay, great. I see another question that we have in the chat, but I want to keep us moving along. We've got quite a few presentations still to get to today. So again, let's give Núria a quick round of applause. And we're going to move on to Vishnu Chandrabalan. Vishnu, if you could please come to the stage.
I can't see the chat either, but can you hear me okay?
Yes, and see your slides.
And you can see my slide, perfect. I'm going to turn the camera off. My network is a little bit dodgy. Right. Hello, everyone. I'm Sean and Paul. Thank you very much for having me again. Sean, you'll have to kind of interrupt me because I can't see the chat if my network starts playing up.
Yes, we had a question. We'll give Vishnu a couple minutes to come back in. But yeah, we had a question from John Gresh in the chat. Are there other well, actually, a couple questions here. He was interested in the reference mentioned creating applications using OHDSI. Are the slides going to be available? Well, John, the slides will be available. Can you creating applications using OHDSI is the topic that he was interested in. Is there a link where he could get more information on that?
Yeah, sorry, by creating applications.
Yeah, sorry. I thought you mentioned early in the talk. I was away from my screen, but I heard it. I thought you mentioned that there was some reference creating applications or creating programs using OHDSI. Is that a paper or a book or something internal, or did I mishear that?
No, yeah, it's a book, an online book that Edward Van is writing, and I have all the links in the presentation. So when they are shared, I guess you can access them because I don't have access now to the chat to share them.
Excellent, thanks. I'm happy to hear that it's in the slides and it'll be available. Thanks for a great presentation. Really interesting. Thank you.
Thank you.
Okay, great. All right, thank you both. It looks like Vishnu's back. Vishnu, let's give this another go.
Thank you. Apologies for that. Can you hear me okay? And can you see my slides? Yes?
Yes.
Perfect. I'll set my timer and I'll try and compensate for that. Thank you, Sean, and thank you, Paul, for inviting me again to Devcon. I think it was exactly a year ago at Devcon. So I was here a year ago, Devcon 2024, when I was speaking about our experience in Lancashire using DBT to map our EHR data into OMOP. And then, over the course of the last 12, maybe 18 months, Katie set up the DBT working group, and we've had a fantastic, I was involved in it initially. I haven't quite had the time to contribute as much as I would have liked to, but the DBT Cynthia project took off big time. I think Katie is here, Lawrence Adams from London, he's also here, and they've gone to town with how much they've done with the DBT Cynthia project. Now, for people who are not familiar with DBT, DBT is a data build tool. It allows you to do your transformation with and gives you table level lineage and a whole pile of goodies around that. Now, we were quite successful using DBT to map Lancashire Teaching Hospitals data into OMOP, and we, for our efforts, we won the HDI UK Team of the Year award last year as well. And this is for as an example, this is what, and this is our data lineage is published online, and this is what our lineage looks for generating the person table. Kind of gives you a little bit of an idea of the complexity of what it takes to construct just one table in OMOP when you have multiple source EHR systems. We presented a poster at the OHDSI Devcon conference, I think in 2023, and then we came back, and this is the bit that we don't quite talk about. It's actually just our ETL is quite complex, and I'm sure all of for anyone who's done data engineering or mapping into OMOP, I bet if you plotted out your data lineage, it will look something like this. But when what we wanted to do was, our ambitions grew when we came back, from having done the mapping at Lancashire Teaching. So I now lead a large secure data enrollment program for the entire region. We have 4 NHS trusts, things like 8 hospitals. The 4 trusts, they have different EHR systems, just the primary EHR, but there's also a myriad of other specialized systems for cancer, for chemotherapy, for instance, for maternity care. The team grew as well because we've been successful in OMOP. The size of the team grew. We grew from a team of 1.5 people to now we have a team of about 6 or 8. And because we used DBT, the wider business intelligence teams and data engineering teams were interested in, this is beyond OMOP, they were interested in, hey, how did you do this? We would like to use these processes for our other ETL work within the region for our BI process, for instance. So just to illustrate what became challenging very, very quickly with DBT, well, the crux of today's talk is going to be don't use DBT. I think that's the punchline. But I'll explain why. If you're considering migrating your existing ETL to DBT, hopefully this presentation will tell you why you should consider SQLMesh instead. We ran into a problem when the team grew and different members of the team wanted to start working with different sections of the data pipeline. For instance, let's take this as an example. We have the procedure occurrence and the condition occurrence tables. That and the lineage of those are represented. One of my data engineers is working on the procedure occurrence lineage, which is fine. And Tim, who's my other data engineer, he's working on the condition occurrence lineage, and there isn't really a lot of clash. But then I go and make a change on the master patient index. I don't tell Quinn or Tim that I'm doing it. I'm their boss. I don't have to tell them. They can figure it out when things break. And of course, things break. It becomes hugely challenging. And the way we tried to mitigate against this was Quinn had her own copy of the entire data, and Tim had his own copy of the data. And that doesn't quite make sense either, because we have about 1 billion rows of data in our OMOP instance, and we are certainly in the bottom quartile, if you like, or even the decile of how big OMOP databases can get. So this clearly doesn't work. that's just one NHS trust. Our ambitions after our initial success at Lang Stitching is that we want to map the data from all 4 NHS trusts in the region into OMOP. We have multiple EHR systems. Each hospital has its own primary EPR, and there are multiple common systems but are deployed at each organization independently. For instance, Somerset Cancer Registry for cancer, there are 4 instances of it at the 4 trusts. And there are some centralized systems. For instance, chemotherapy and radiotherapy use a single centralized system for the entire region. That's what our current data estate is for routine direct care is. But we've also built a single regional Databricks lakehouse. That's what I've been responsible for, leading a large team over the past 18 months. So we have a single Databricks lakehouse in Microsoft Azure that connects to all of these 4 NHS trusts. We now have a centralized team of data engineers, not only for OMOP, but also for operational and business intelligence. So collaborative data engineering went from being a nice thing to have within my little team that was doing OMOP to becoming a necessity for the entire region. We also wanted to build out the OMOP medallion architecture on Databricks. When we presented our work at the RC conference, one of the unique selling, well, may not be so unique anymore, but one of the unique selling USPs at the time was that we were able to refresh our entire OMOP database every morning. So we were on a 24-hour cycle every morning. But not all of our tables. Some of our tables would get trunked. It would get rebuilt from scratch, like the little ones, like person table, which has only got 2.5 million rows. But the big tables, especially measurement and observation, would get refreshed, updated incrementally. So we were able to build what we call a silver OMOP layer, which has clean but re-identifiable or identifiable data, which we use for near real-time use cases such as antimicrobial stewardship or sepsis surveillance or monitoring for kidney injury. We also have built a gold or an Eden certified layer of our OMOP database, which we also then use for things like clinical trial feasibility analysis using Trinatext. But having done this for Lang Stitching hospitals, we wanted to do this for the entire region. So there won't be 4 silver layers or 4 gold OMOP instances. There'll be one OMOP instance for all of Lancashire and South Cumbria, for all 4 NHS trusts, and then eventually primary care as well. And we didn't think we could do it with DBT. I don't think we could have done it with DBT the way we had done Lang Stitching's hospital. So enter SQLMesh. So as I said before, the option we really can't have a data dev environment where we replicate our OMOP data set per engineer. That simply does not scale. And especially if you're doing this in Azure, you want to be very frugal. You want to be clever about how you use cloud resources. Databricks bill you for consumption. Every time you spin up a serverless instance, you get billed for it. You want to have a low barrier for entry for data engineers who may not be familiar with things like Ginger templating, which DBT heavily uses a lot. Most of our data engineers in the region are SQL first data engineers with a little bit of Python knowledge. So we wanted to kind of target them. And we wanted to be dialect agnostic. So nearly all of our on-prem estate is SQL Server based. There's some Oracle and Postgres. And of course, Databricks is Spark SQL. What we didn't want to do was manage a code base that was Transact T-SQL and another code base for Spark. We wanted to write in a SQL once, and we wanted to deploy it either on SQL Server or on Databricks. And especially for medallion architecture, because bronze, silver, and gold are all OMOP conformant with different levels of privacy and data quality, we wanted to be able to, we could engineer on Cynthia, on DuckDB, and deploy the same code to Databricks. So I'll speak very quickly. I think I'm 9 minutes in, so I'll talk through, over the next few slides, I'll talk through the core CSQLMesh features. Please check out their website and their documentation. There's a lot more than these core features: transpilation, column level lineage, virtual data environments, incremental refreshes, model blueprints. The fundamental difference between DBT and CSQLMesh that people will have to wrap their heads around is CSQLMesh remembers state, whereas DBT does not. So SQLMesh knows when we last ran a model, for what time intervals, and what the actual queries were. Not the string representation of the query, not the string representation of the queries, but what the queries actually mean. So SQLMesh behind the scenes uses something called SQLGlot. That's also an open source library built by the same team, which takes your SQL. It's a little bit like SQL Render in OHDSI, I guess. It takes your SQL query and can transpile it from, let's say, Spark SQL to PostgreSQL. And it does a very effective job of that. And you can transpile between 21 different dialects of SQL. But it goes beyond that. It can understand if your SQL is a select statement, or if it's an insert, if it's a truncate, or if it's a delete. It can understand what the columns are, and it converts all of it. Takes your SQL query apart and builds something called an abstract syntax tree, so everything becomes a Python class or a Python object, which then allows SQLMesh to do some really clever things, such as column level lineage. So you can track exactly how a column in a downstream model came to be. And you can also track column level lineage when a downstream column is derived from 2 or more upstream columns. And even when columns are tucked away within CTEs, SQLMesh is able to pick that up beautifully. And this is what you're seeing on screen is actually a screen grab from the SQLMesh UI. Virtual data environments. I don't think I'll be able to explain this paradigm very, very well. I've tried it several times and I've always failed. So please go on their website, and they have a really nice YouTube video on this. But essentially what SQLMesh does is when you build your data warehouse or your lineage, it builds a physical layer, which you see at the bottom of the screen, and you builds views on top of the physical layer. So when you query the person table, or you say select star from person, what you're actually doing is you're doing a select star from the person view, which is a view of the physical person table. SQLMesh manages the physical layer. What that then means is that, let's say you have model A and model B, right? And you create a new virtual environment on the right, which will also have the model A and model B views pointing to the same physical table. Now you have two virtual environments, but they're well, you have a production environment and you have a virtual development environment, but the development environment is inexpensive in that all it is a bunch of views. In the case of OMOP, it will be 35 views pointing to the same 37 physical tables that the production environment is pointing to. Now a data engineer comes along and changes, let's say, the person table. The only thing that they've changed is the person table. SQLMesh will automatically recognize that you've changed the person table, and it'll create a new physical person table, only the person table, unless what the changes you made have impacts on affect other tables. So now you have, out of the 37 tables, all your other physical tables remain the same. You have a new view in your development environment that's pointing to the new physical person table. And once you run your test and you're happy that that new table is correct, you can then merge it back into the production environment. And when you do that, once again, SQLMesh, you're not rebuilding the person table in the production environment. All that's happening is the person view in the production environment is now pointing to the person table in the physical layer. And I'm pretty sure I've confused all 136 people on this call. So please watch the YouTube video that the SQLMesh guys have put out. SQLMesh also does incremental refreshes, but it does it very differently from DBT. DBT, when we did it, certainly the only way of doing it was using a maximum timestamp column in every model that we had, every model that we wanted to refresh incrementally. But SQLMesh does this differently by using time intervals, which is particularly useful when you're starting off and you're having to build a model that with 20 years worth of data. This is a new feature, and it's particularly useful, especially for us when we have silver and gold OMOP layers. Model blueprints. What model blueprints allow you to do is to have a single SQL query in code in your code base, but execute it on any number of different layers. For this is a simple example of how we have set up our Achilles queries to run, rather than running it on our Achilles queries are once they go into production, they'll be incorporated entirely into our transformation pipeline. So from an orchestration and scheduling point of view, Achilles will run when the silver layer finishes running every day, if we choose it to, or if our gold layer, if it gets refreshed every month, Achilles will just run at the end of it. And rather than have two sets of queries two sets of Achilles queries, you're able to create one set, and then as you can see here, you can simply specify blueprints. Hey, run Achilles on all of the silver models and run Achilles on all of the gold models, and you will have two sets of Achilles outputs in your data warehouse. So how are we using SQLMesh? At Lancashire Teaching Hospital, we've migrated nearly 80% of our DBT code into SQLMesh. We expect to finish the rest in the next 4 weeks. We're building out our OMOP medallion architecture. We are able to develop and test on Cynthia, on DuckDB, and we deploy the same code to Databricks. We have set up the GitHub CICD bot, which comes with SQLMesh core. So when a data engineer is working on their own feature branch and when they generate a pull request against the main, the GitHub CI/CD action automatically creates a virtual data environment in our Databricks warehouse where it will run the data quality tests and data quality audits and tests for review before we can merge into main. SQLMesh is being developed by a company called Devcon. So we've just completed a proof of concept with Devcon Cloud, which offers better observability, debugging, and scheduling. Around the same time that we set up DBT Cynthia, I set up SQLMesh Cynthia as well. I haven't done very much work with it. It did work last year. It should still work. So if you want to have a play with it, that's the GitHub repo. And we also have our medallion architecture, the early version of our medallion architecture code in there as well. So just to say, this is what we are building, and this is why we are doing it. For us in Lancashire Software, OMOP is much more than for research. We're very keen to use OMOP for real-time intelligence as well. So our OMOP database currently, the on-prem version of our OMOP database currently feeds into things like sepsis dashboards, chronic kidney detection algorithms to support primary care, things like antimicrobial stewardship. And a lot of this data requires data that is reasonably fresh. So in summary, the biggest benefits of SQLMesh as opposed to DBT or anything else is your development environments are really, really cheap. They're like GitHub branches. You use them and you throw them away. You get column level lineage, which is particularly useful if you want to bring in new members of the team. You can see breaking and non-breaking changes. So if you if you change an upstream model, SQLMesh will detect if that's going to break anything downstream and will only rebuild models that it needs to rebuild. So from a cloud consumption cost point of view, I think this is SQLMesh wins over DBT. And it comes with all of these stuff that DBT also has, but I think SQLMesh does things a little bit better. Things like incremental updates, tests, and unit tests and audits. SQLMesh does have, needs a slightly different setup to DBT. You need to set up a state management database, and you'll have to wrap your head around the paradigm of state management. If you have a reasonably sizable data engineering team of more than one wanting to work on the same data pipeline, I would strongly recommend at least having a play with SQLMesh. From a collaborative data engineering point of view, it has been particularly useful for us. That's me, and I've got 3 seconds to spare. Sean, thank you very much. I can't see the chat, so if there are any questions, I'm happy to take them either now or please reach out to me on Teams or GitHub or email.
Yeah, we could take 2 minutes for a question here. Daniel, looks like, yeah, go ahead.
Yeah, quick question coming from the chat, Vishnu, and just point of clarification, especially as somebody that moved from the free model of SQLMesh over to the Tobiko Cloud. What has been your experience and the differences there? Because there is certainly some concern that, like with DBT Core, it was really great to use until they started locking all of their features behind DBT Cloud. But what has your experience been thus far with like Tobiko Cloud, for example?
So we have that's a great question. So. And DBT Cloud has, I think the criticism has been that not only have the log features, but DBT Cloud and told hike their prices several fold in the last 2 years. I've seen some LinkedIn posts. We have, from a feature set point of view, Tobiko Cloud looks really good in the sense that it takes care of scheduling for you, and it also takes care. It also gives you a nice observability platform for things like for when you run your models. But from debugging, the experience was been really good. But we have not tested Tobiko Cloud in anger because we've only completed a proof of concept or proof of value with it. Right? From a feature gating point of view, the only feature gate that I've seen so far, aside from things like looking at logs, it gives you a really nice interface to look at logs and navigate your logs. The feature gate that I've seen is I can pick this up with you outside of this. In terms of column level breaking changes, I think there's some difference between what Tobiko Cloud does and SQLMesh does. In terms of the general direction, it's early days to say how many new features will get locked behind Tobiko Cloud. But the core is good enough for a lot of what we do. The SQLMesh core is phenomenally good.
Right, great. I hope that answered the question. I know we cut out a little bit there, but Vishnu, thank you for your gracious offer to accept questions directly. But yeah, thank you. Excellent presentation. Let's give Vishnu a quick round of applause. We throughout some of our earlier presentations, we had a couple mentions of the technical advisory board and the role that they play in Odyssey. We've got Frank Defalco coming up next to give us an update what's going on in the technical advisory board of the tab in 2025. And please take the stage, Frank.
Thanks, Sean. Can you hear me okay?
Yep, and see your slides.
Great. So my name is Frank Defalco, and I'm going to be giving an update around the technical advisory board, which, as Sean pointed out, has been mentioned a few times through some of the lightning talks today. Quick background on who I am. So I was the original, as it was called, benevolent dictator of the Odyssey open source community, author on Atlas and Aries Indexer and Web API, current package maintainer on Eunomia and Achilles, and contributor on ETL Synthia in the DQD. Professionally, outside of my Odyssey roles, a computational epidemiologist on the observational health data analytics team at Johnson & Johnson, and the chair of the Odyssey Technical Advisory Board. So what is the TAB? The TAB is a group that's focused on guiding and supporting the technical and development aspects of Odyssey open source projects. It is comprised of experts from across the Odyssey community and external partners. We work to ensure the stability, security, supportability, and sustainability of Odyssey open source projects. And we do all this through meetings the first Friday of every month at 10:30 Eastern Time. TAB has a couple commitments that guide the way in which we approach the things that we take on. First is transparency. We try to keep the TAB processes and technical decisions open and accessible to everyone. The second, collaboration, working closely with the Odyssey community to foster technical innovation and excellence. And inclusivity, ensuring that the diverse perspectives are considered and valued in the Odyssey technical discussions and decisions. I'm going to take a minute or two here to make sure people who are interested in participating in the TAB or joining the TAB calls understand how they can get involved. And it is an open invitation. The TAB is not limited to a specific set of members. anyone is welcome to join the tab discussions and contribute to the agendas. So to join within the Teams environment on the OHDSI Teams tenant, you will see the work group for open source community. If you dive into that, within it, you will see a sub-channel called the Technical Advisory Board. So that's a way to get access to chats, discussion, links to where the team meeting and calendar for that team meeting is available. There are recordings and OneNote document that maintain the notes and discussion topics across all the meetings for the past 2 to 3 years. So going back over the last few years, accomplishments in 2023 included the deprecation of the OMOP CDM 6.0, lots of fun stories around 6.0, the OHDSI open source ecosystem scope, so work to define the scope of how the open source ecosystem was working, acknowledging different platforms and approach across that community internationally. In 2024, we had several sessions where we discussed learning with federated networks. There was discussion and decisions around Java versioning support, some discussions around release cycle coordination. And one thing about this is, so the tab is not a group that dictates to other teams how they develop. It is a group that tries to participate in many of those working groups and then internally discuss and then disseminate through participation in other working groups. So there is the idea that, one working group will be discussing a change that is discussed within the tab, and then if there are other working groups participating, there's the opportunity to hear about that and acknowledge what changes may have impacts. There was discussion around SQL generation standards. As people familiar with some of the stack know, they've used SQL render. In our last talk, we heard about SQL GLOT as another alternative. So there was some conversation around how those different packages can be supported across the OHDSI network. Database support planning, which databases we support, how we do testing in CICD environments, and some updates to our communication site, which has been published. So far in 2025, we've had some conversations around how the Technical Advisory Board functions, which I just kind of commented on, how the Technical Advisory Board doesn't dictate the actual standards or technical architecture, but rather serves as a meeting place for those conversations to occur. One of the things we've tried to focus on for this year is going to be a OHDSI 2030 technical roadmap. And again, in that effort, it's a coordination, not dictating a technical roadmap, but trying to understand how the different working groups can put together in collaboration a roadmap for where things go with OHDSI's technical architecture in 2030. Again, that working group coordination, we've been trying to reach out to different working groups, ensure there's participation from different working groups, bring information from the tab to those, and hoping that the reciprocal happens. And one of the ways in which we're doing that is reaching out to some of our different chapters around the world. So upcoming in May, the OHDSI Africa chapter will be presenting on their work within the tab, along with looking for some guidance around architecture decisions that they're looking to make going forward. To join the journey, our next meeting is Friday, May 2nd at 10:30 Eastern. I have links here to both our GitHub as well as the new tab site for those who would like to see the content that's there or access the GitHub. We take updates and contributions via pull requests. So if there are things that you would like to see discussed and or included within the technical advisory board's scope, that is another way to do so.
All right, great. Thank you, Frank. Do we have any questions for Frank? We got a couple minutes here if we want before we move on. Just scanning the chat. Looks like we don't. All right, great. Thanks, Frank. Let's give Frank a round of applause. And we're going to move on to our last lightning talk presentation before we move to the developers dialogue. I expect we will actually have a few minutes for questions after the final lightning talk. So if there's any earlier presentations that anyone has questions about and wasn't able to put those in the chat, probably have about 10 minutes after in between to ask those live. But for now, let's bring Anthony Sena to the stage, who's going to give us an update on Strategus.
Yeah, thanks, Sean.
Hades.
Yeah, let me share my screen. Hopefully everyone can hear me.
We can hear you great, and we can see you.
Yeah, thanks again for having me. This is my third Devcon presentation, and it's my third Devcon presentation on Strategus. So I wanted to just provide the community with a quick update on what's happening with Strategus and to talk a little bit about how you can get involved with the project and with Hades. So the biggest question I get with Strategus sometimes is just how do you pronounce Strategus? And so we've had a couple of ways in which we would say the word Strategus over the years. And so we've standardized that based on the Oxford Dictionary. And the word Strategus actually means the leader of an ancient Greek army. And in our context within Hades, Strategus is an R package for coordinating and executing analytics using OHDSI Hades modules. And so it is our R package that we are using to run studies through OHDSI and specifically network studies across the OHDSI network. And as mentioned earlier, this work is standing on the shoulders of many giants within the OHDSI community and within the Hades working group specifically. So many thanks to the many maintainers that contribute to these packages and to our working group. So Strategus as a project actually started in 2023, and it started as a piece of beta software, which is denoted by the version 0 here in this kind of basic looking Lego vehicle. And during 2023, we used Strategus for some network studies, and through a lot of good collaboration within the community, we obtained a lot of feedback important to the use of that design of Strategus that informed a redesign of Strategus in 2024. So within 2024, we actually formed a sub-team of the Hades working group that focused specifically on some of the challenges and pain points with Strategus version 0 and came to some agreements on how we would want to restructure the code and the approach for using Strategus. And that work kind of came to fruition at the end of 2024, where we released a version 1.0 of Strategus, and it was then added to the Hades library of packages. So a lot of good work and contributions from the working group itself and from the OHDSI community, who was instrumental in providing that feedback. So it wouldn't be an OHDSI presentation if I didn't talk about standards, since that's an important part of what we do here in the community. And so with Strategus, there's kind of three pieces to the way in which we want to represent, execute, and work with results from studies. So we have within Strategus a standardized input. And the idea here is that the choices that you make for a particular study design are captured as a JSON document. And all of those decisions that you've made are kind of committed to a repository. They are transparently provided to anyone that wants to run your study, and it uses all of the Hades libraries to run the various analytical packages that you want as part of your study. The standardized execution of Strategus includes all of the Hades packages, and we use an R package called RENV, which basically provides us with an enumerated list of all of the R libraries that are used to execute a given study. Coming out of the execution, each of the modules within Strategus and their Hades counterparts produce CSV files that have all of the results from running the analytics. And the idea here is that this provides transparency as to what was produced as running the analytics. And so people can take a look at those results prior to providing them to a study coordinator for the network study. So the Hades modules and the analytics may need to be combined in different ways depending on the aims of your study itself. So as I mentioned before, every study design is captured as an analysis specification JSON document. And so you can think about each of the Hades packages themselves being these composable Lego bricks in ways that you can design your studies so that you can make use of the Atlas cohorts in Cohort Generator and design, say, an incidence rate study like we did for the How Often large-scale incidence rate study. You might also want to do a prediction study using the PLP package, and so we have a module that supports that. Recently, the Martin Van Kessel and team have contributed the treatment patterns package both to Hades and as a Strategus module, so that is now part of the stack that you can use as part of designing your network studies. And there are, of course, estimation modules that you can also add in and the characterization package. So one of the things I tend to gloss over because most folks are not necessarily interested in how these actually work at a code level is how would you actually use one of these building blocks to design your study. And so to kind of showcase this a little bit, I'm going to use the characterization module and the characterization package from within Hades. And so with this new version of Strategus, the way that these modules work is a bit different than if you use the kind of beta version of it. And so just to walk through what this code looks like and what it's doing, at the very top here, we load up Strategus in that first line where we call the library function. Once Strategus is loaded up, now you have access to all of these building blocks or modules. And so on the second line, you can see that we actually create a new instance of the characterization module. And if you're familiar with object-oriented programming, this is essentially using a class to then create an object that you would use. And this characterization module object has a function called create module specifications. And this is where you define the standardized inputs that you want to use when you're running the characterization package itself. And so if we look at some of the arguments that go into this specific module, we can define the target IDs or the cohort targets that we would like to characterize. We also may want to characterize those folks within the target cohorts that experience an outcome or do not experience an outcome in a certain time at risk, which is what these remaining parameters describe. And so once we've created those inputs there, we can actually take the inputs and then add them to the analysis specification as shown below. And that analysis specification object can be serialized to JSON, and that JSON document, that analysis specifications JSON, is what defines the analytics that will run through Strategus and through Hades. So as I mentioned before, we use a package that is built and maintained by the R team called RENV. And what RENV does is it provides a reproducible R and Python environment that we use for all of our network studies. And so if you take a look at the RENV lock file, it is a JSON document that describes all of the packages that go into the execution environment. So that includes all of the Hades packages, which now includes Strategus itself. And so when you take the analysis specification I just described and the RENV lock file, you have essentially a reproducible standardized execution environment for running Odyssey studies using Hades. And so on the standardized output side, once you've actually run through the study, these modules produce results in a folder per module that has a CSV for each essentially result set that you produce. And so Strategus and its modules then provide functions for loading these results into a results database, which then allows us to visualize the results using some additional Hades packages, specifically the Shiny App Builder and the Odyssey Shiny modules. So these work together to allow you to review the standardized output for studies that are executed through Strategus. So we bring this all together using what we call the Strategus study repository template or the study repo template. And so Strategus itself provides the hooks into the Hades packages, but we need some way to also deliver the RENV lock file that provides that standardized execution environment. And so this repository template pulls all of that together. And this repository template is what we will be using to create new network studies within OHDSI. And so in addition to the Hades libraries and the Hades libraries and Strategus, it's also providing this template provides some additional scripts that help you design your study, as well as documentation on how to work with the with the template itself. So we are currently in analysis April. If you've been following along in the OHDSI community, we have these guideline-driven evidence studies that are happening. And so as part of trying to help the community get ready to run those guideline-driven evidence studies, we've designed a new sample study that's now embedded into the Strategus template I mentioned. And so this sample study was developed based on information from the OHDSI Evidence Network, so that this study should be able to run at every site and produce some level of results. But in this particular instance, the ask that we have is that you just run this study, but the results themselves is not something you need to provide back, but instead it's just to verify that the infrastructure that you have is ready to run all of the guideline-driven evidence studies that are upcoming. And so a couple of weeks back, I gave a presentation on this as part of one of our OHDSI community calls. And so I've linked here in this QR code and link the YouTube video that goes through my presentation, that if you want to dive into those details and run that study at your site, that will hopefully be a helpful resource. So I wanted to just talk a little bit about the Hades modules that are inside of Strategus, because they have changed since the last time I gave this presentation to the Devcon folks. And so the Hades modules inside of Strategus, they take that standardized input we've talked about. It provides a interface to connect the connection details to your CDM, and then certain execution settings like where to write the results to perform their analytics and produce the results that you need. And so in addition to all of the results, there's an additional file that I'll talk about in a minute that's used to basically define the structure for those results that we can then use to upload to a results database. So a Hades module is essentially an implementation of an interface. So if you're familiar with object-oriented programming, this Strategus module and its public methods that I'm showing here on this slide is essentially like an abstract-based class that you would implement for your specific package to make it work within the Strategus infrastructure. And so to do something like that, if someone were to want to add a new module to Strategus, the process looks like this. So first and foremost, you need to get your R package into Hades. And the reason why we want those packages in Hades is so that we can essentially make sure that you are adhering to OHDSI best practices around code management and testing and documentation. And so it also allows us to identify who is responsible for maintaining that package going forward. So that is the first step. And I would like to also just shout out the treatment patterns package that Martin Van Kessel has been leading, because he has most recently kind of worked through this process with us to get treatment patterns into Hades as well as into Strategus. So first step was we got treatment patterns into Hades, and then from there, Martin implemented the Hades module in Strategus. So part of that included design and implementing all of the standardized inputs that would then run through the treatment patterns package. He provided a mechanism where he implemented the method for execution, and then he defined the results model and the ways in which the CSV formatted files would be done so that they could be loaded into the results database. And then ultimately, you need to provide a mechanism to upload. And within Hades, we have the results model manager package, which helps facilitate that work. And to talk a little bit more about the results model manager package and this notion of a results data model specification, when we talk about the results of a study, right, we need to load those up into a database so that we can run the Shiny application I mentioned earlier. And so this RDMS file, as we call it, a results data model specification, just provides us a standard way of describing the data definition language for the results themselves. And so each module has its own results data model specification file. And as part of that, the results tables in our results database have a prefix corresponding to the module that generated the results. And the main reason for this was to just avoid any naming collisions between table names that different modules might produce. In addition to the module results tables, Strategus produces a single table at the moment called database metadata, which just gathers some information about your OMOP common data model. And specifically, it uses the CDM source information to just get a description of the CDM that was used to produce the results that appear in all of the module results files. So there are a large number of tables that are produced when you use Strategus, if you use all of the modules themselves. And so some of the feedback from the community was, hey, it would be great if we had some documentation on how that results model looks and works and describe all of the tables and columns. And so as a result, we've used this open source tool called Schema Spy so that when we do new releases of Strategus, all of the tables and relationships amongst those tables are documented and are now part of the Strategus documentation, which lives on GitHub. And specifically, you can go to this results schema and take a look at all of the results tables and the relationships so that when you are trying to pull together results from your study, this will hopefully be a helpful resource in terms of knowing which tables to join to potentially pull out data from the results model itself. So if you'd like to get involved with Strategus or Hades in general, we have our working group meetings are the third Thursday of each month at 12 o'clock. And our next meeting is on the 15th of May. So please join us if you're interested in Hades or Strategus. Additional ways that you can get involved is you can review, there's many GitHub issues as Paul noted earlier. So feel free to peruse those or post to the Odyssey forums if you're interested in just helping out or finding ways to get involved, or you can email me directly at sena@odyssey.org. So thanks again for your time and attention, and I'll be happy to take any questions that you guys may have.
Yeah, thank you so much. And if there are any questions, please add them to the chat. We'll take a look at that. I guess, so can you talk a little bit about how you've added issues for first-time users or trying to figure out ways for new contributors to be involved with your projects?
Yeah, we do make use of, there's a tag on some of the issues where it might say like help wanted or good first issue. And we have some of those, I'd say, scattered about Hades. I'd say for folks that want to get involved, I think there's just different levels of involvement as well as different levels of expertise. So I do want to thank John Gresh specifically, who's been helping guide some of the chirons, and they've actually been doing a lot of testing and providing feedback with Strategus to, again, like just help us to see what it's like for a newcomer working with the project and kind of like giving us feedback as to like where there may be gaps in the documentation or things are not clearly laid out in terms of how to set up your development environment and things like that. And that feedback does go a long way and is very helpful.
Have you gotten, the whole goal is to reduce the effort and costs of implementing a network study. Do you know of any, do you know of how many sites have been able to use it as part of a network study, or how many network studies have used it so far within the last year?
Yeah, I don't know if I have exact counts, but we've been using it for some of the Odyssey network studies over the last 2 years. And I can think of like Cindy Kai has been leading a study on the semaglutide that used it. There are a number of upcoming guideline driven evidence projects that are going to be using it. And I see Katie in the chat had asked if we're using Strategus for internal studies at J&J, and the answer is yes. So we are doing all of our analytics, or nearly all of our analytics, using Hades and Strategus as part of that. So I think in terms of like, if you just wanted to run a study at your site and it wasn't necessarily a network study, you can absolutely use Strategus and Hades to do that and use the same template to kind of follow the patterns that are there. That's
great. And has that, have you had to do updates to like the network study GitHub repo to incorporate Strategus?
Yes. So one of the major changes that we made with Strategus that I don't know if I mentioned as part of this, we fundamentally changed the way in which we are using the RENV lock file. So in the beta version of Strategus, those Lego bricks that I was showing earlier, each one of them had its own RENV lock file because each of our Hades packages kind of had their own environment that they needed to run the analytics. And so one of the big contributions that Martijn made in the last year is that he actually created a Hades-wide REV lock file that essentially provides a runtime environment that's compatible for all of the Hades packages. And so that greatly simplified the way in which we can make use of all of the Hades packages. And by extension, we changed Strategus to fundamentally use a single execution environment across all of the Hades packages, as opposed to having these like kind of cordoned off Lego bricks.
That is so exciting in how we're trying to make it more reproducible to deploy it. I know we certainly have used it here, and we've certainly seen a significant decrease in the effort in implementing a network study. I'm also interested if we've been able to get any new network study data partners to start off with Strategus and see how if they've been able to implement that as a new data partner within our evidence network.
Yeah, I think that's, to that point, we certainly want folks to try and run that Odyssey example study that I mentioned, right? So that'll be a great way for you to get your feet wet with just getting the tools installed and just verifying that you can make use of it to just execute the study. And I think a nice logical step from there is to then think about designing your studies with Strategus and Hades to do your own work. And so I think there are a lot of opportunities as it relates to the design of studies with Strategus where we can certainly use some feedback, because that may not be as approachable as we would like. And I think there's a lot of work that we can do to collaborate and make that process easier and simplified. I see John's got his hand up.
Yeah, John, you want to have a question?
Hey, Anthony, can you hear me okay?
Sure can. Hey, John.
Yeah, thanks for the shout out, by the way. Yeah, I love the idea of running that example study. Not for anybody implementing a new study. One of the things as a software developer that I always like to have is a jumping off point, something that I know works. And then if anything breaks or anything isn't working, I always have that reference that I can go back to and build up to and say what's the difference between what I'm doing and the version that works. So and I know that study is built into a Strategus template that you've created. And so users can actually download that template and run that example study pretty much out of the box. And so, like I said, as a developer, it's so much easier to work and troubleshoot and build new things when you have a known version that works. So I love that about what you've created. Thanks.
Yeah, thanks for that, John. And I think it is one of our goals within Hades is to provide a kind of testing suite around that template that I mentioned. So, to John's point, like we want to make sure that what is in that Strategus template as we make updates is fully tested, and so folks can rely on that to do their network studies or even use that for their internal studies if desired.
That's great. Well, thank you so much. Do we have any questions for any of the participants from our lightning talks? We certainly. It was great. I know we actually only touched a small part of the contributions made this year, but we wanted to try to give some areas we wanted to highlight some new projects, and we also wanted to highlight some of the areas that we're making some important movement as a community as well. And so we tried to make it a mix of both, but there's just a ton of stuff that we can't get to on a regular basis. And so I really encourage you to take a look at the repos and see which ones might be of interest to you. It's pretty easy to either clone it or to follow it and be able to see what types of changes have been made. I did have a quick question for Vishnu, and it's really nice. And I really like your deliberate discussion about how you've looked at DBT and you've now working with SQLMesh. What's interesting is these things, what I love about open source, it's not in a vacuum. And we've seen significant changes in the DBT community over the last year to adopt some of the functionality that SQLMesh has done. And so I kind of want to see, how has that changed any of your calculus on how DBT is trying to adopt some of those functionality?
It's challenging, and it's the landscape is constantly shifting, isn't it? With these tools. So I think the key is it's the reward versus the challenge of adopting a new tool or migrating away. For us, migrating away from DBT was relatively easy to do. And we've reduced the amount of ginger templating. And as we bring more data engineers on board, most of our data engineers are primarily SQL based with some Python knowledge, very little R. So I don't have a good answer to that, Paul. I think we like what we see in SQLMesh. It's possible that you may invite me again to Devcon 2026, and I may come back and say, "Hey, don't do SQLMesh. Go back to using DBT," right? but it's a question of what tool you're most productive with, or what your teams are going to be most productive with. And right now, we seem to be moving relatively fast with SQLMesh, where we couldn't do with DBT, especially when you're working as a team, we couldn't do that. And I don't think you still can with DBT. It's possible that may come. But right now, SQLMesh seems to let us move fast. So we've jumped on the SQLMesh train. Yeah, that's a little bit of a non-answer, but.
No, actually, that's exactly what I want. It's a philosophy. It's about the tools. It's about understanding that if you use some of the newer tools, there might be a little bit more technology support or overhead, but it's really it's basically your risk tolerance that you're at what you decide to be able to do to take advantage of the functionalities. I just hope that when we're writing the chapter in Odyssey on data operations, that you're a major contributor to that chapter, because what you're doing in terms of the lineage of how the data is being prepared from the source systems and being projected is under such a great level of control. It is really one of the best practices that I've seen in ETL.
Thank you very much, Paul. I'd love to contribute.
Yeah. It would be great to conscript you into that book chapter.
It looks like you have volunteered me, so.
It's well, the key. One of the keys to our success is conventions, and if we can ETL the data the same ways, then and if we can manage them in the same processes, we can, it really will improve the quality of our data throughout our network. So I really like that you're using open source tools, and that you're willing to share how you're using them to improve that effectiveness in your organization.